Good afternoon, everyone. Thank you for joining us today. My name is Jordan Edgington. I'm an Air Force veteran, and I'm excited to present our project Disclone to you. Before we dive into the details, let me introduce our team. Along with me are Tom Childress, an Army veteran, Nathan Pennington, a Navy veteran, Jordan Yamada, a Marine Corps veteran, Adrian Garcia, an Air Force veteran, and Stephen Thomas, a Marine Corps veteran. Disclone is a full-stack chat application inspired by Discord, designed to provide users with seamless communication experience. Whether it's for casual conversations, team collaborations, or gaming communities, Disclone offers a user-friendly platform tailored to various needs and preferences. One of the exciting aspects of developing Disclone was our team's shared interest in exploring and mastering new technologies. Rather than focusing solely on creating a feature-rich application with existing technologies, we saw this project as an opportunity to expand our skill set and push the boundaries of our knowledge. As a result, we decided to challenge ourselves by incorporating cutting-edge technologies that we were eager to learn and implement successfully. These technologies not only enhance the functionality and performance of Disclone, but also represent significant milestones in our journey of continuous learning and growth. A quick high-level overview of some of these technologies we explored include the use of multiple back-end servers, our static page front-end or client, a persistent database paired with a caching service, and the utilization of containerization for ease of development and production. I will now pass the floor to Tom to get into more of the specifics of some of these new technologies.
Hey everyone, I'm Tom, and today I'm going to go over a low-level look at our architecture and the structure of our application. Here's our main GitHub repo, here's our README, a little bit about developing on the source code, but here we're going to go into our architecture documentation. So here you can see our client. Our front end was built with React and TypeScript. Our back end was built with Django and Django REST framework to support our synchronous GUnicorn application. And our Django channels were used to serve our asynchronous Daphne application. Caching was provided by Redis, and our persistent data lies in PostgreSQL. So here is an illustration of how the WebSocket server kind of works. So our client makes a handshake with the WebSocket server and sends a message. Once it sends a message, the WebSocket grabs that message from the one client and distributes it to every single client that's connected to the channel. To better illustrate, the client makes a handshake connection request with the server. Once that is received, the server maintains that connection open with the client. Then messages are sent back and forth between the server and the client. And finally, when the client disconnects, the connection is closed. Another illustration of how to do this is we have two clients right here. Each client connects to the WebSocket server when they enter a channel. Once they enter that channel, that connection remains open and it listens for either client sending messages. Once a client sends a message, as we discussed before, it is sent out to every client that's connected to that channel. Additionally, these two clients can make requests to our GUnicorn server. Once it makes a request, it grabs the data from the PostgreSQL database, or when it's sitting in the caching layer in Redis, and sends it back to the clients. And then that connection is closed until the next request is made. Another illustration of these two different types of connections is on an HTTP connection. The client sends a request, the server takes that request, sends a response, and the connection is terminated. However, with a WebSocket, the client makes the request to connect to the server, the handshake is made, and the connection is maintained until the client says, I want to disconnect. Finally, for containerization, we use Docker and Docker Compose in order to make this application come to life. Passing around code was very difficult with a lot of the dependencies that we used, but containerization made this very easy. Additionally, it made it very easy to produce and deploy this application because all we had to do was open up an Elastic Cloud Compute instance, pull the image down, and spin it up in there.
Hey everyone, and welcome to our demo session today. I'm going to show you how to navigate our platform using two different accounts. We'll cover signing up, creating a server, creating a channel, uploading images, and engaging a live chat. First, let's look at the account we already have As you can see here, I'm currently logged in as Happy Dad. Next, we'll go ahead and create a server by clicking on Add Server here. And now that the server is created, you can see up here, we're able to access it. I'm going to go ahead and create the channel we're able to talk in. And the server ID is 13 at the moment. And I'm going to go ahead and have Jordan join us so we're able to engage in chat and you're able to see the live functionality. Awesome. As you can see, Jordan is here and he's talking to me. All right, let's switch gears and sign up with a second account to demonstrate how easy and quick the process is. Here, I'm going to input my information. And as you can see, I'm now signed up with my new account, Happy Man. And here I'm going to show you guys a bit of the customization we allow here. We're able to adjust our username if needed again, and we're able to add an image as well. Now here I'm going to go ahead and add an image. I'm going to navigate to my desktop and upload an image here. Image is updated, and I'm going to go ahead and navigate to a server. There we go. And actually, I'll join a server that already exists that we currently have. And on the left hand side here in our channel, you can see that the images are uploaded for Jordan and I. And that concludes our demo. Thank you for watching. And if you have any questions, feel free to ask.
Hey guys, I'm Nathan, and I'm going to go over our project planning, user experience, and agile workflow. For the initial project planning, we knew that we wanted to have the minimal viable product to allow the user to join a channel, join a server, and chat in real time with other users. Here we see an example of a user story for posting a message. After consolidating these user goals, this led us to sketch out a wireframe of how we wanted our app to look to allow the user to accomplish these goals. Next, I want to show how we use Trello to implement an agile workflow by breaking up our features and design decisions into smaller tasks. This allowed us to divvy up the project into smaller chunks and assign them to different members of the team. And that's it for project planning and user experience. Up next, we have Yams.
Hey all, I'm Jordan Yamato, the Yamster class. As mentioned, we took this project as the chance to explore and tackle as many new technologies as we could. Containerization with Docker, incorporating TypeScript with React, utilizing WebSockets and Django channels for real-time chat. But really, the biggest challenge was balancing our feature scope with our time constraints. Learning curves were steep, and much of our time was committed to troubleshooting. A lot of pain points, but plenty of growth too. We definitely had many discussions on how we could accomplish as much as we could with the limited time amount as possible. We compromised quite a few features, but we got a lot, I think, accomplished. I'm now going to pass off to Stephen, and he can talk more about the features that we have planned for the future.
Hi, I'm Steven. I am now going to discuss the future features the Disclone application will have. These features are voice and video using WebRTC. This technology is used for peer-to-peer architecture. We can facilitate direct communication between users without the need for a mediator and ensuring low latency and high quality audio and video transmission. Also, adding clear and accessible tools for users to control and make changes to video settings. all the while protecting users' privacy using encryption protocols, maintaining scalability and performance throughout changes made to the application, and ensuring the integrity of Disclone still meets user needs. Overall, implementing these core features for our application will improve user experience tremendously. Now, closing remarks from Jordan.
Thank you guys for watching our presentation of our application Disclone. If you guys have any questions, please let us know. Thank you.
All right, that was Disclone by Edge, Tom, Adrian, Nathan, Steven, and Jordan. And we have a question here from one of our streaming services is what made you choose Docker over other options for this project?
Hey everyone, I can take that one. So initially, it was kind of a rough start. We had a lot of pain points with it, but the main reason for choosing Docker in the beginning was because of the multiple services that we were using and system requirements for everybody. Passing around images and being able to use the same containerization allowed us to develop code using the same containers and the same kind of OS virtual machines, and regardless of like our operating system on our local machines. Additionally, in the end, it made production a lot easier. We were able to deploy the compose image up to an EC2 instance much more easily than a manual deployment. Also, initially when we were planning the project, I wanted to think about scalability the most. And for the future features of this project, I'd like to use tools like Terraform and Ansible to get our infrastructure written out very well, and then use an orchestration tool such as Kubernetes to orchestrate multiple replicas being made of our containers, and using a tool like Amazon EKS to make our application very scalable, both vertically and horizontally.
That's a great answer, Tom. Really appreciate it. To piggyback off of that, when you chose to do this project and build it in the way that you guys built it, it seems like there was an intent for creating some sort of CI/CD pipeline. Were you guys able to implement something like that during your work process, or is that going to be a feature later on to come?
Unfortunately, I think that'll be a feature later to come. We tried to implement it at first, but I was having issues with Docker Hub, and also we were troubleshooting a lot of underlying Docker issues in people's systems. It's a really nice tool, but it takes a lot of configuration and a lot of learning in order to implement. So this past 3 weeks has been a lot of learning about Docker and Compose and sort of the pitfalls of Compose versus using tools like Swarm or Kubernetes. So the more that we learn about infrastructure as code and the more we learn about orchestration tools like Kubernetes and Swarm, I think more features will be built later on in order to really make the orchestration very good and scalable for this application.
That's great. Awesome. Does anyone else have any questions for Disclone? All right. I do have one final question. Your guys' icon, is that supposed to be a stormtrooper? Or what are we looking at here in the icon?
Yeah, I could take this one. Uh, yeah, the idea is that it's based off of like the clones from Star Wars. I think when we were design or choosing the project, Adam was referencing like maybe doing like a Reddit clone or a Discord clone, and the term clone just stuck out, and that's where the logo came from.
I see. So it's a Clone Wars kind of reference here.
100%.
All right. Okay, thank you so much.